Welcome to the November edition of our JSC and Journal of Statistics Education and Data Science Education webinar. I'm going to go ahead and share my screen. We'll go do some introductions here. All right, so we're going to be talking about do data competitions improve learning? A paper that was done on a student performance, engagement, and experience with Kaggle InClass data challenges. If you have noticed, I am not Nick Horton. So I am going to be taking over moderating this webinar series from here on out. I'm at a small college in Columbus, Ohio, if anyone cares. So I used to do the activity webinars, and we haven't done as many of those in recent years. So I'm switching gears and doing this. Just a little advertisement for what's new in the journal. If you haven't been over there in a little bit, some of the more recent papers. I know I'm particularly interested in the team-based learning to teach data science article, as I know many of you are moving into data science roles, teaching data science courses. That looks like it's a very interesting article on collaborative learning in the data science classroom. All right. Just one quick announcement. There's no webinar in December. We will return in the new year, so look for announcements about that. And just to keep you kind of up to date with what's going on in CAUSE these days. So the undergraduate statistics project competition is ongoing. There is a link there. You can also just find it by Googling to CauseWeb. I believe I read the submissions for the fall project competition are December 22nd. And being that I put these slides together a few weeks ago, I sort of wasn't thinking about the fact that this would be after the undergraduate statistics research conference, which happened at the beginning of this month. But I left it on the slides because there were some great talks there. If you didn't get a chance to view it live, there are recordings of all of the different talks, so feel free to go and check that out. And the link is there on the slide. All right, so to introduce our speakers today, Julia, am I saying your name right? Julia Polak?
Yes.
Okay. Is a lecturer in statistics at the University of Melbourne. You may have noticed that we're meeting at a slightly later time because there is a substantial time difference between here and Melbourne. So I appreciate you all, both of you being up this early in the morning. She has a broad range of research interests, including non-parametric methods, forecasting, and data visualization, and has many years teaching statistics and data science for different audiences. And then Diane Cook, our other author, is a professor of econometrics and business statistics at Monash. Am I saying that right? Monash? Okay. In Melbourne as well. And her research is in data visualization, especially high dimensional data using tours with low dimensional projections and projection pursuit. And current focus is on bridging the gap between exploratory graphics and statistical inference. And I think with that, I will hand it over to our speakers and let you guys.
Thank you, Leighton, for the introductions, and thanks for the invitations, and many thanks for everyone who joined us live today. Me and Di are very happy to be here and tell you about our experience of running data competitions in our classes. I must admit that Di, she's a real veteran of this field. She's run data competition in her classes for many years, at least 5 or 6. At least I first heard about the data competition from Di. And I found this very interesting and immediately wanted to try it in my class. So today I will briefly chat with you about why data competition in the first place, a bit about the platforms that we used, the Kaggle InClass platform. I will tell you about our experience, our experiment, and about our findings, of course. And I also would like to dedicate a fair amount of time to chat about what we learned and what we can recommend you when you will try it in your own class. Next slide, please. In the past few years, the educational community started to collect positive evidence about data competition. It's things that students engage it. It's bring the game feel into the class. Also, we see that students look like it's helped them to perform better in the exam. When I run the literature survey, I found quite a few blogs which chat about how great the data competition is, how students enjoy it, but without too much data to back up stuff. I also found several peer review papers with much more solid data and quantitative reports, but unfortunately, none of them have been done in the field of statistics or data analysis. And here with DIE, we provide a statistical analysis of data competition in class, how it's influenced students' performance and engagement and general joy in a framework of statistical class or data science class, if you wish. Next slide, please. So before I will describe how we exactly run the competition, I would like to talk a bit about the platforms that we use. We use the Kaggle InClass platform. It is a platform for running prediction analysis competitions. It's very easy to use. It's very flexible. You can control a lot of stuff. For example, you can limit the people who you would like to participate. So it can be really close competition for your class only. You can choose different loss functions. There is a list of about 15 of them. You can limit the number of the submission, and it's worked perfectly for different type of response variables. One of its greater features is that it has the dynamic invisible to all the leaderboard. So you as an instructions can see all the time what your students up to, how they perform, and students can see each other and their peers and say, oh, somebody performed better than me. Maybe I will try and beat and perform better. It also has a hidden board for final performances to prevent gaming from the side of students when they compete. Next slide, please. Okay, today I will concentrate more on the experience of my class that I taught in a UniMel because we have only about 20 minutes. So in 2017, I taught the computational statistics and data mining subject. It's a postgraduate level for students with math, statistical, and information technology or bachelor background. So those kids are really strong from a mathematical and statistical point of view. I covered many regression topics and also many classification models. And overall, I have 61 students. So I split them about half and a half. Half of my students participate competition about regression models, and the other half participate in the competition about the classification models. So it's kind of mimic the randomized control trials. Remember that in the live teaching room, it's very hard to perform a clean experiments like in the clinical trials, but here we tried our best. So my students compete the first 60 days as individuals. Each of them build their own models and upload their own predictions. And in the last week, I allowed them to form groups and collaborate and maybe explore a bit more about this idea of mixing models. Next slide, please. So we use two separate data sets, of course, for each of my competition, of each of the competitions. We use the model property action price for the regression competitions. Here, students were expected to predict price based on the property characteristics. And we also use the spam classification data set for the classification competition, of course. And here students try to classify if the email is spam or not. It's worth mentioning that both data sets are large, very challenging to predict. So students really need to try their best, and was with a lot of errors. So it wasn't straightforward experience for them. Also, both data sets have been collected by me or by DI, so the students didn't have a chance to see the outcome for the entire data sets, only the ones that we share with them. Next slide, please. For the findings. So we found that data competitions improves performance in the exam in the relevant topic. To examine this, what we did, we calculate for our students the performances score for the regression topic questions and for the classification topic questions. And those questions, by the way, was predefined immediately after we wrote the exam. And here on these two graphs, you can see the performances scores on the regression, the classification question for both of my cohorts. On the left side, I have the cohort of students who participate in the classification competition. And on the right, sorry, I'm mirrored. And on the right, you have the graph that summarize the performances of the students that participate in the regression competition. So if you will look on the box plot, you can see that the median for the topic that related to the competition topic was higher in each of my slides. And it was also higher than 1, and I will tell in a minute where this magical 1 is coming from. We also ran a permutation test to examine the difference, and I'm really pleased to report that we found that the difference in the median was statistically significant. Next slide, please. Okay, so how did we calculate these performances indexes? And why I'm looking on the one below 1 or above 1? So again, after writing the exam, I identified the questions that was related to regression or the classification. And then I took the percentage of the success in the regression questions and divided by the percentage of success in the total exam. Similarly, I did for the classification questions. You can maybe think about like normalizing the performance of the student on the examined topic relevant to its own abilities or its own level. And the logic here is that on average, students' success rate for each question will be about the same as the overall success if he understood all the questions or all the topic at the same level. Understanding one topic better than other will result in higher success rate for the questions about this particular topic. So, if the students got a performance score higher than 1, that means that the students performed better than expected. He did better on this particular topic. If the value of my score was 1, the performance score, it indicates a consistent performance on this topic as for all other topics. And similarly, if the performance score is lower than 1, that means that he understood or performed on this topic less than expected. Next slide, please. This graph illustrates maybe in some different way the positive influence of the data competition on our students. So here I plot a scatter plot of the regression questions performance scores versus the classification questions performance score for each of my students. So each dot is my student and its location depends on the score on the different type topics. Okay, I have here one horizontal line. Oh, sorry, you cannot see my mouse. So I have the horizontal line on 1, and I have the horizontal line, a vertical line on 1 as well. So does help us to define the areas when the students outperform or underperform for each topic. So if we will concentrate our attention on the right upper side, the yellow upper side, yes, that's one. Here we meet all the students that outperform on the regression questions. They perform better than we expected in the regression questions because they score above 1, and underperform on the classification questions. And here, not surprisingly, we found more students that took part in the regression competition, okay? And similarly, if you will look on the bottom left side, the other yellow, yes, bit, yes. Here we meet a student that outperform on the classification questions, but underperform on the regression questions. And again, we see a majority of students in this area that participate in our classification competition. So it's another clear evidence that, you know, taking part in the competitions help the students to improve their knowledge on a topic of our competition. Next slide, please. Okay. We also examined the influence of data competitions on the students' engagement, and we measure engagement by the number of submissions. How many times they submit new predictions into the platform. And we speculate that a student who is more engaged in the competition may learn more about the material and consequently perform better on the exam. And we found that the positive correlation between frequency of submission and the performances in the competition. However, we found very weak relationship between frequency of submissions and the performances in the exam. So it doesn't matter how often he participated, it still will help him to understand the topic better and perform better in the exam, despite if you make 3 submissions or 23 submissions. It's also anecdotally, it seemed that students who participate in the regression competition submitted on average more times. I don't know why. That's something that we saw. Next slide, please. So when I run my competitions in University of Melbourne, I parallel at the same time, exactly the same semester, run competition and class that she taught in the University of Monash. The setting of the competition was slightly different. The cohort was slightly different as well, but the findings were exactly the same, which is great. And due to the time limitation, I will not go into the details what exactly happened in Di's class, but you are more than welcome to read it in our paper. Next slide, please. Lastly, we are examining how the data competitions influence the interest of our students. And for these purposes, we run a survey. At the end of the semester, we ask them all kinds of questions. Did they found it fun? How they think the time investment was worthwhile or not? How it's helped them to understand the material, what they think about how it's helped them, and so on. So you can see a bit of the summary of the questions that we use. And overwhelmingly, the response to the competition was positive in both classes, in my class and in Di class as well, especially the question on the enjoyment and engagement in the class and obtaining a practical experience. So we see that students look on that competition in a very positive light. On the next slide, please. Can we move to the next? Yes, I just summarized a few of the testimony of the students to the one of the open questions. So you can see that overall students found the competition useful and fun, and as a great experience. They also wish to see more of that competition in other classes as well. And they say that the Kaggle platform was very easy for them to use, and actually seeing the performance of the other peers encouraged them to perform better. Next slide, please. Okay, so by now, I hope that I convince you that data competition is good for your students. And hopefully you would like to try it as well in your class. And remember, much more details are in our paper. Now I would like to talk about what we learned and what we recommend you to do in your own classes. So in the first two lines, you have links to videos. The first link, it's a short video that I created, which will take you step by step from organize your data to uploading and make all the choices in the Kaggle InClass to set up your own competitions. And the second link is an official explanation from the Kaggle team. Now to our recommendations. Setting competitions is extremely simple and straightforward. The hardest bit, seriously, is to find a proper data set. As soon as you have your proper data set, all the rest is running very smoothly. So your data sets should be rich, clean, large, and unfamiliar to your students. And preferable, use some data set that you collect by your own. And on the next slides, Di will chat more about different data sets that she's used in the past and give a few of her feedbacks as well. Next, when it's come to the random splitting the data to training and testing data sets, try to do it fairly randomly and make sure that the both data sets are balanced. For instance, if you're talking about the Melbourne prices, having all the one-bedroom apartments only in the test data set, it's not a good idea at all. So keep it balanced and split it about half and a half. That's what we did in our competition. Lost functions. You have about 15 predefined loss functions in Kaggle platform. Choose one that you wish. Just again, keep on this balance between the theoretical performances of your lost functions and the simplicity of use. Students are more happy when they understood intuitively what the loss functions is doing. We, for instance, limited the submissions of our students for one submission per day, which forced them kind of to think and try really to improve their model before the next submission that they are doing. Working in teams or in individuals, each of them has its props and cons. And I probably will say that the hybrid approach is the best. Something like what I implement in my class. First part individual, second part as a team, and the final mark will be some combination of the performances in both parts. Or like the Di, what she did, she's allowed to her students to form teams at the very beginning, immediately, but each student made its own submission to the platform and wrote its own report. It's also a great idea to provide a baseline, some kind of baseline. So we calculated a baseline model, the simple model that we could thought for each competitions and upload its performance. From the side of the lecturers, it's help you maybe to find some problems in the data quite immediately. From students' point of view, it's encouraged them, you know, to beat something and to start and work on the material. It's also really recommend to share students' models in the class, and students actually really interested to see, okay, what other people did, how they build a model, why their model perform better than mine. And it can be done via maybe a short presentation during the class. And if you don't have a time to this during your class, maybe ask your students to write create some short video, 5 minutes video, sorry, and upload it to your the website of your subject. Related to the final grades, remember it's a time consuming and resources consuming from the students' point of view, that they actually put a lot of effort in those kind of activities, so reward accordingly. We choose to give 10 points overall for this activity, and we split the point 40% for the performances in the competition and 60% for the performances in the final report. For the competition, we gave full mark 4 points for the person who get the first place, 3.5 points for the second place, 3 points for the third place, and also substantial places receive 1.1 points less than the previous one. And in this strategy, the students feel that they have kind of fair chance to get a good mark on the competition, even if they're not in the top 3 or 5 students, and they will still try and work hard on the competition. Timing. This competition probably better to put on the second part of the semester, because you need to cover material to students to try and apply it. Try to finish it about a week, better even 2 weeks before the end of the semester, because the last week or 2 of the semester are very stressful to the students, and you want them to do the competitions out of this stress. And keep the duration to the competition fairly short, 3-4 weeks at most, again, because it's takes a lot of effort from the students. And probably the last point that I will mention, that we also included a lot of resources in our website for the students to reach about different models, different presentations. And I know that at least in my class, because I chat with the students actually went to those extra resources, read them, watch the videos, and found them useful. Right, next slide, please. So as I mentioned, I used competition for many years, and I will pass the microphone to her. She will chat more about different data sets that she's used and what she's found, what's working, and her experience about the data competition.
Thanks, Julia. So I've managed to keep doing Kaggle competitions in the classes that I teach, but I can't split the class up in the same way that Julia managed to split her class. The class that Julia taught had both regression modeling and also classification, machine learning type models. And so the design that Julie did was absolutely amazing. But I'll tell you a little about the type of data sets that I've used in the last few years, because I have a lot of fun in putting data sets together. So starting back in 2015 was the first time I ran a Kaggle competition in Melbourne, and that was for the machine learning class, where we mostly focus on classification models. And I put together a set of data based on paintings. Oh gosh, I forget the guy's name, but it's one of the 538
Bob
example.
Ross?
That's it, Bob Ross, the happy painting. So I put together that. So that was a very difficult task, because the paintings needed to be classified into groups, whether there was a forest or a lake or a house or something like that, that I had manually tagged. Same class in 2016, that there were 2 instructors, and we recorded our voices saying different things, different statistical terms. And that was a data set provided to the class to predict. And then 2016 was the time that we did the competition for this experiment. And in that year, I was teaching just a statistical thinking class, which focuses on regression. And so I ran the Ames housing prices sorry, actually, that's not true. 2017 was the time we did the competition together. I wasn't teaching the machine learning class, but I gave the spam and ham data to the person that was teaching that. But it wasn't done in a way that could be used to support the experiment that we're running. But I taught the Melbourne auction, the statistical thinking class, we did the Melbourne auction prizes for that. In that setup, that class has got postgraduate students and undergraduate students. The undergraduate students are actually very competent. The Monash, in a sense, has a very high entry requirement for the undergraduate students, particularly in the commerce bachelor. And so I typically find that the undergraduate students perform, some of the best scores in the class are undergraduate scores, and some of the worst scores in the class are undergraduate scores. And the master students are a bit more consistent around the middle. So the undergraduates formed the comparison group for my part of the experiment, because they didn't do the Kaggle competition, only the postgraduate students did that competition. And in the last 3 years, I got data from Tennis Australia, that is ball tracking, where they manually tag the end of a point as a winner, an error, or an unforced error. And so the students were required to make a model to predict those. 2020, we used Google Sketches. There's a Google tool where you can sketch an object. So it's an image analysis problem. I picked 6 different images for them to work from and downloaded from Google: boomerang, kangaroo, crab, lots of 6 funny things to try to predict what that image was. And then this last year, we used Victorian bushfire data, which is data that we collected ourselves in order to study the terrible bushfires in 2019 and 2020. That's all I have to say about the competitions. It is a lot of fun, I think, pulling data together for this type of activity in class.
I know one of my questions was going to be, how do you find or get the ideas for the data sets? Because I know Kaggle has its repository, but it sounds like you're actually doing your own, putting together your own data sets for this.
I think there's a really good reason for that, because some students are very resourceful at finding full data sets if they're out on the web. So working with your own data. So it means that you need to be friendly with people that are collecting data and get data from them, or if you're working on your own problems as well. So as I said, the 2019 data was from Tennis Australia, and their goal is to be able to automate a lot of the statistic collection. As you've seen this last 2 years, they now don't have line judges because the ball tracking is used to make the line calls, and they can do that fast enough to call the lines. Similarly, things like tagging a point to end as a winner or an error or an unforced error is a really manually intensive task. And if the ball tracking data can be used to predict that, then that saves quite a lot of resources. So it's actually very accurate. And Pictionary, one of my students was working on just finding interesting data sets for their visualization project, and created a small R package to extract data from the big Google collection of images. And so that just seemed like a good task to do. And the bushfires was just something that I was working on because I was interested in. So either working on data tasks that you're working on, or if you find collaborators or other people around the university that are working on interesting problems.
Are there any guidelines or limits that you would put on sort of how many data points and how many variables, or does it really just depend on the problem?
So it is it needs to be achievable. And so that's the purpose of putting the baseline model together that Julia mentioned. So you need to build a model yourself and make sure that it does a reasonable job at predicting your test data set. So as long as you can do something reasonably well, the students should be able to do that too. So you need to proof it yourself. You need to leave. I think it's really important for students not to have very clean data sets today. And a problem like this is where they're getting some practical experience. You don't want to leave it so messy that that it's just not a good predictive analytics task. So doing a little bit of data checking ahead of time is important. The thing that I think is the best learning experience is building variables. We call it feature, gosh, I've forgotten that. But basically the variables that you give to the students in the data set, often what you need to do in a problem is actually transform variables or create new variables. And that's a really important skill to learn. So having a data set where actually you'll get better predictive accuracy if you work your variables a little more, not just use the variables that you're given, is an important part. So that's good to have. Yeah, feature engineering. Sorry, Nick. Yeah. So it's good to have a few hiccups in the data, because they should be able to get them over that hurdle in order to be capable once they get out into the workforce. So.
We did have a couple of questions, and if there are more questions, please feel free to put them either in the question answer or chat them. I don't know if you both have seen these, but I'll just read them anyway. My question from Nick is whether you have data about the characteristics of students who didn't engage with this. Were there subgroups that didn't benefit or felt alienated by the competitive aspect? Did you find that at all?
Julie, you want to take it?
Yeah, I probably will pick up. Unfortunately, we haven't done that kind of analysis yet, because it was, we was more concentrated on overall picture, and we haven't had too much. We didn't put a lot of time to investigate, a particular subgroups. Again, anecdotally, without too much backup, when I look on how many times every student's submitted, for instance, I couldn't find no one that submitted less than about 5 times.
Okay.
So in my class, at least.
Okay.
It's usually, oh, sorry. Yes.
Oh, I was just going to ask another question. Please go ahead.
Yes, I just wanted to say, it's usually, some activities are usually like any activities. There is a particular characteristic for students that more engaged and less engaged. No, we haven't examined it, and it's a great idea to examine it further. And if more people will run the competition in their class and report them, we can all collect the analysis and see, what kind of students benefit from this more or less.
So
yes, Lee.
Just adding a little bit more to that too. Yeah, it's something we didn't study, but you do see. So there's a few things that can be done to mitigate it, I think. So the scoring for the competition, I've put it into categories more than actual exact score. So that if they get improve on the baseline by 5%, they get a certain amount. If they improve on the baseline by 10%, they get a certain percentage. So that relieves some of the competitive stress, and then it puts it more towards how well is my model doing rather than them. And students can have an anonymous name in the competition. They don't need to be identifiable. And so you can avoid that feeling of shame if they can't get a really good model because of that. You still do find some students that don't participate and that don't even score as well as the baseline. I mean, which again, we probably should be trying to talk with those students some more. It's something that to think about going forwards. And the other part, as Julia said, is predictive accuracy is only a part of it. Having a separate report where they write up what they've learned about the data problem and how they went about constructing their model is an equal amount in terms of the marks. And we also have tended to have the students, when they at the end working with the team, put together a video of what interesting things that they found. So the only time I found the students had, quite a few students were really a bit angry about things was the Pictionary challenge. It was a very difficult classification task, and the best models were using deep learning models. I mean, that makes sense, we're classifying images. And so they had to do a bit more work to learn a bit more than what we talked about in class to be able to fit those models. And I think that because a lot of them were commerce students, they also said it's not an economics problem. So why are we working on this? But there's still the large part, people were just very engaged. And it just provides that ability, that chance for them to be creative and see how their skills might transfer out to the public. Yeah.
So we did have one sort of related question in terms of engagement. Julie, does it seem like your data suggests that students engaged more with regression problems compared to classification problems? Was that the case? And if yes, why do you think that was the case?
It was definitely the case. So the average number of submissions of students in the regression competition was higher than in the classification competition. Why it's happening, I can only speculate. One of my speculation is because maybe they learn about many regression models before the subject as well. So they found, they wanted to try other stuff as well. And with the classification models, most of the students, this was the first times that we chat with them about support vector machine and stuff like this. And maybe there was, less creative, or less thought about there is other options, how much I can explore, how much I can transfer my variables, how much I can create different combination, but no, nothing solid.
Oh, no, that's fine. So the other question was about sharing maybe some syllabi in the courses that you use the data competitions. We can talk about, maybe we could post those on Cause with the webinar recording if you feel comfortable with that. So
I think that the exam questions are definitely as one of our appendixes.
Okay, it looks like Diane did
syllabus.
post something there.
Yeah, I just put the link to the machine learning class that I teach. The materials are all publicly available.
Okay.
Yeah,
Yeah, if there's anything else that you want to share with the slides, I think we would be happy on Cause to post any of that if it's not already in the slides. And then I do apologize. Susan had her hand up, but I'm not good at running a Zoom panel. If you could type your question, I'm actually not sure how I actually do this.
There's another question in the Q&A too by Abhishek.
Yeah, let me see if I can figure out, allowed to talk, I can do that. Oops, that was the wrong person, sorry. Susan, are you still there?
I am. I just clicked the wrong button. I'm sorry.
Oh, that's okay. I'm learning how to do this.
My students do that all the time in my classes too.
Welcome to the world of Zoom.
Yeah.
All right.
It's super interesting, by the way. Thanks.
Okay.
Very welcome.
All right. And then we did have, yes, one more question. Did you check students' methodology for arriving at an answer? Or is it mostly focused on how well the prediction and classification?
So the answer to that is yes. Yeah. So that report that they write afterwards is, yeah, if they're, we have very, well, part of the setting up is to have a data where you don't know everything about it either, but you know enough to know what's appropriate, and then roughly. So that the report is the part where we are checking how the students approached it and whether the methodology was appropriate. And things like, you know, if they missed that there were a bunch of outliers in the data that affected their accuracy and they didn't address that in their report, then they would lose marks for that. So yeah, it is actually really important to have the students report more about how they approached a problem and also what things they found in the data, because predictive accuracy is not on its own enough.
Okay. Well,
so
thank you.
They will be rewarded for the prediction accuracy with this 40% on the performances, but the rest will be examined in the report.
Okay. Well, I just want to thank Julia and Diane for waking up very early to talk to us. The recording of this will be posted. Thank you all for attending. A reminder that we do not have a webinar for December, but look for announcements for the new year. And I hope you all have a wonderful holiday, whatever holiday you might celebrate. And it was nice to see everybody. Thank you.
Thank you.
Thank you.